Alright, welcome to the Zombie vs. Skeletons multiplayer game demo walkthrough. This is an update to the original demo for MOBA Skeletons vs. Zombies that I did. It's built off of a rudimentary multiplayer structure created following a Devslopes Unity Academy module in Game Institute, which is a 38-hour course on Unity development and scripting in C#. The original demo was built using the old networking API in Unity, which is being deprecated, and so I didn't really dig too much into it at that time. But since then, it's been driving me crazy because I really want to learn it, and Unity has started to release some of the information and documentation on the new MLAPI, so I decided to work my way through it, and this is the result. So if we're just picking up from where we left off in the last one, I want to talk a little bit about what's new. So I totally redid the whole game from scratch, recoded it all, used the new Unity MLAPI networking, and this is the result. So, gameplay. It's zombies versus skeletons. Skeletons are controlled by human players. Zombies are controlled by the server AI, and the object is to get the most points by the end of the game, which is timed. When the timer runs out, whoever kills more of their opponent team members wins. I designed the gameplay structure. The original version was just moving around and attacking in order to demonstrate the networking concepts in Unity. It wasn't really a game, but I created a game out of it, and what you're watching is me and my kids playing the game under each of the 3 different difficulties. So, what did I do above and beyond the course tutorials in here? One of the things I did was the user interface, created the title screen. I replaced the generic network buttons with custom buttons and fields following the style of the game that I created to match the interface. Added some gameplay option selectors so you can choose the duration, whether it's 3 minutes, 10 minutes, or 15 minutes. And before the game starts, you choose the game difficulty. I added a countdown with the players joining, and then also on the server or host, there's a start now button so you can bypass the countdown and just jump in and start playing the game. There's the heads up display at the bottom during the game, which shows the scores, the time remaining, and what difficulty setting it's on. And then I also added an exit game button because you got to be able to get out when you want to get out. One thing that I changed, if you notice on the player that's the local player being controlled, it has this player halo underneath it. It has a blue ring and then a green disc inside. The blue ring just shows you like, hey, this is the player you're controlling, and then the green disc shows you how many health points you have left. As it goes down to nothing, when you die, you respawn and you start over again. I went with the disc and the halo because it's more intuitive and it's more adaptable to like future game modifications. Like if I change the hit points and stuff, it's not a numerical output. I did have an issue with that I fixed, which was that when you were hovering over one of the decals in the environment, the cracks in the ground, it would interfere with that. But I just figured out that I went in and updated the render sorting layer to avoid that overlapping so that the health disk is always on top. I made an enhancement to the camera control, so you can press the F key to focus on your player character. So if you're moving your camera around and you lose track of where your player is, you can press the F key and that will angle the camera towards your player, turn the camera. And I had some challenges with that because I wanted to keep the camera angle the same, so I was rotating the camera but keeping the up-down angle still at the same angle. So what I ended up doing was I used quaternion with a modified Euler angles to achieve that effect. But the big difference is using the new MLAPI for Unity. I've rebuilt the whole networking from the ground up. Did not follow the tutorial because the tutorial was for the old API. So MLAPI, very interesting. It was kind of a challenge to work through it with this new and limited documentation. What I found was that a lot of the documentation and examples were either very simplistic or they were pretty advanced. There wasn't much intermediate resources available yet for the kind of thing that I was trying to do. So I had to make the best out of what I had and stretch my thinking a little bit, and I did a lot of experimentation to figure out, how did things work and what would be the best way to do things. One of the things I did was I decided to break out some of my scripts into server scripts and client scripts to just kind of abstract things a little bit and help with some of the crowding and repetition, and just break things out. And it was something I was thinking about when I did the original implementation for the old demo. And when I was going through the documentation, I saw that the boss room example, which is a pretty advanced example provided in the Unity documentation, but they use that approach, and it's kind of cool to see an idea that I had as something that's actually being used. So I used the client scripts mostly for client RPCs for navigation and animation triggers and audio. When I went and started doing the MLAPI, I was seeing that it's server-based, so I was using the structure of everything happens on the server. If it doesn't happen on the server, it doesn't happen. The server owns everything, and the players they just pass their inputs to the server, and then the server does everything for the players itself. Now, it works, and it works pretty well. I know that sometimes the thing that makes it easiest to code isn't necessarily the thing that's going to give you the best and most responsive game, but that was the approach that I took for this one, and it worked pretty well. The one thing, when I first started doing it, it's like server-based, but then you create a player object, and then the player object is owned by the client, and the server can't do things with navigation or animation triggers or audio because it's owned by the client and the server doesn't have ownership of it. So what I ended up doing was I broke out the player into two objects. There's a player object, which is basically an empty that gets spawned and created when a player connects to the game, and its job is just to keep track of the player and the connection and to collect the player inputs and pass it to the server. The server creates a player character, which is the actual little skeleton that you see in the game, and that is owned and spawned and respawned by the server, but it's controlled by the player by passing its inputs through to the server. And that's worked out pretty well. Worked out really well, actually. Made things a lot easier once I did that. One of the other things I added was the enemy AI. It's one of my first forays into AI scripting for enemies, and so the way that it works is the enemies have a decision cycle. Every 4 to 8 seconds, the enemies make a decision whether they're going to attack or run away. And that 4 to 8 seconds, those are configurable in Unity because they're serialized fields, and so when they reach the end of a decision period, then it will randomly choose between 4 and 8 seconds on when to make the next decision. And that was done, it's a bit of randomness in there, right? So they seem a little less mechanical, and it's a little harder to predict what they're going to do or when they're going to change because you don't really know. It makes the game seem a little more natural playing. So when they make their decision, they're either going to attack or run away. Most of the time they're going to attack, and most of the time they're going to attack the nearest player. But occasionally they will attack another player just to kind of mix things up, and occasionally they'll run away. They're more likely to run away if they're low on health because that kind of better simulates human decision making. And then if they're in the middle of a cycle and there's some interruption, like a targeted player is dead, well then it bypasses the wait time and it goes right to the next decision point. A couple other things, the game difficulty, easy, normal, hard. What I found was that the key factor in game difficulty was the speed of the enemy movement, since the players have a ranged attack. Messing with the enemy hit points, it helped to a certain degree, but really the key point was enemy speed. So that's what increases when you get to the harder levels. I added a bunch of animations that weren't in the original game. I mean, they're in the characters and they're in the prefabs, but I broke them out and coded them for the spawning and the hit damage and the die animation, adjusted the zombie walk speed a little bit because it was too fast and it looked weird. I added the background music and sound effects using an audio mixer. I fixed some of the navigation issues, and then I updated the fireball logic to make it run a little bit more smoother. But that's it. Thank you for watching.